So today we're going to take a look at this discriminant, and we are going to make a foldable here. So here's the top corner of it, and what you are going to be doing is folding down the corner, and let's see, I think I have a picture of this. So it will look like this, and the corner that we're going to focus on right now is this top one right here, this discriminant one. So that corner should get folded down, so you can write this, discriminant equals negative b minus 4ac. That can get written as you fold this one down here. So the quadratic formula, if we were to write it in this box, that's x equals the opposite of b plus or minus the square root, b squared minus 4ac, all divided by 2a. And what the discriminant is it's this part that's right underneath. So that value is the discriminant. And you guys we've been working with this the past couple days. It tells us the number of solutions, and we've dealt with real and imaginary. So if underneath that square root symbol is positive, we know that there are two real solutions. We know if what's underneath there is negative, we say that there are two imaginary. And what we haven't talked about is if it's 0 underneath there. And if there's 0, there's one real solution. And that makes sense because we would have plus or minus the square root of 0, so it would be plus or minus 0. So it wouldn't give us an extra one. So the next one, we're going to look at this, and then we'll figure out what to put out on the front of it. So our discriminant, our b squared minus 4ac. And it's hard to see, this is supposed to be a plus right there. So we have 10 squared minus 4 times 1 times 25. Well, that's 100 minus 100, so our discriminant is 0. So what does that mean? One solution. That means it crosses x-axis once, or it hits the x-axis once. Intercepts might be a better word. X-axis one time. So let's see, if we were to factor this, let's see what those solutions are. X squared, 10x, 25. So we multiply those together, so we have 25x squared. So it's got to give us 10x, so that's 5 and 5. So 5x, 5x. So we got x plus 5, x plus 5. So it factors into x plus 5 times x plus 5 equals 0. So you can see the solution for both of these is x equals negative 5. So that means on our graph, 2, 3, 4, 5, it only hits it here at negative 5. And let's see, it's a positive a, so we know our quadratic would look like that. So this one has one solution. So let's fold down that corner there, and let's put the discriminant equals 0 right there. So the next one we're going to take a look at, let's look at this bottom one here. 6x squared plus x minus 15. So we have b squared minus 4ac. So 1 squared minus 4 times 1 times negative 15. And let's see, so that is, oh, that should be an a right there. So this should be times 6. Let's see, oh, that's 60, right? 4 times 15, so 60 to 40. Let me see here. Let's just go back. So 1 squared. So 1 squared minus 4 times 6 times negative 15. We have 361. Now that would make sense because that's 360. Alright, so 361 is our answer. So what does that mean? That means that there are two solutions. It crosses twice. So where are these solutions? So let's see, we can do a box and circle again. We'll see if this one's factorable. 6x squared, we could do the quadratic formula too. So if we multiply this, 6 times negative 15, so that gives us negative 90. So let's see, 90 and adds to 1, well that'd be 10 and negative 9. So we got 10x, negative 9x. So factor, what goes into 6 and 10? So we got 2x, so that means it's got to be 3x. So 2x times what gives us 10x? We got 5. 3x times what gives us negative 9 minus 3. So we have this one factoring into 2x minus 3, 3x plus 5. So we know we have to set each of these to 0. So this first one, let's see, we would add 3 and divide by 2. The second one, we'd subtract 5 and divide by 3. So that's where it's crossing the x-axis. So we have it crossing at 1.5. And let's see, that would be negative 1.66 repeating. So it looks like that. And, you know, so we know it looks something like that, but we know it crosses twice. So we can go back to that one. And this is where our discriminant was bigger than 0. So you can fold that over and put that it's greater than 0. So the last one we're going to take a look at. You guys are right, this is going to be the less than 0. So let's see, b squared minus 4ac, 1 squared minus 4 times 1 times 5. b squared, I'm having trouble with my letters right now. That should be 2 squared. So we have, let's see, negative 16. And since it's imaginary, you know it can't factor. So I'm going to use that quadratic formula. So x equals the opposite of b plus or minus. Well, we already know that this is negative 16 divided by 2a. So 2 times 1. So this would be 2 plus or minus 4i divided by 2. And we can divide those both by 2. So we have 1 plus or minus 2i. And so these are imaginary, so let's graph this, x squared plus 2x plus 5, and let's see what it looks like. So we got x squared plus 2x plus 5. So we can see, yeah, it definitely does not cross the x-axis there. So it looks, whoops, that's not where I meant to go, right here. So it is hanging out right here. So what does that mean? It means that they're imaginary. Now the last thing we're going to do is take a look at a couple questions. So you might need to add these to the next page. I don't know if you'll have room underneath. You might. But our goal is to find a k value or values. Maybe there's more than one. So the function has the given number of solutions. So the first one that we're going to look at, let's say we have y equals 2x squared plus kx minus 6, and you want it to have 0 solutions. So that means we want it to cross the x-axis only one time. Well, what do we know? We know that that means our discriminant, b squared minus 4ac, has to equal 0. So let's see. So we have k squared minus 4 times 2 times negative 6 has to equal 0. So this would be k squared minus 48 equals 0. So k squared equals 48. So we have k equals plus or minus the square root of 48. And some of you might recognize, well, this is, if you want to simplify it further, plus or minus, this would be the square root of 16 times the square root of 3. So if we simplified it, it would be 4 square root of 3. So the second one we're going to look at, let's say we have y equals kx squared plus 3x plus 2, and you want it to have two solutions. Well, let's see, two solutions. That means it crosses twice, so our discriminant has to be greater than 0. So we can substitute in, we got 3 squared minus 4 times k times 2 has to be greater than 0. So 9 minus 8k has to be greater than 0. So subtract the 9. Negative 8k is greater than negative 9. Divide by negative 8, and when we divide by negative 8, our direction has to change, so it has to be less than 9/8. So there's quite a few numbers that would give us 2. Now the last one, this one might be the trickiest, and we're going to take a look at y. Let's say we have f of x equals negative 3x squared plus kx minus 2, and you want it to have two imaginary. So imaginary, b squared minus 4ac, has to be less than 0. So we have k squared minus 4 times negative 3 times negative 2 has to be less than 0. So k squared, let's see, that would be minus 24 is less than 0. K squared is less than 24. And this is where things get a little tricky, is these inequalities and when we take the square root. So we know we're going to square root this. So it's not like an equal sign where we can just do plus or minus. So we know some value squared has to be less than 24, the square root of 24. So if k was positive, it would just be k is less than the square root of 24. But k, if we square a value, it could also be negative. So we're going to say, what about negative k also has to be less than the square root of 24. So k has to be let's see, divide by negative 1. Wait, I thought about that backwards. Hold on a second. Let's back this up here. Whoops. So let's think about this kind of like on a number line maybe. K needs to be less than the square root of 24. So we got 24, but we also are going to have negative square root of 24. So for it to be less than, it could be in between these values because the square root of 23 would be less than that, positive and negative, the square root of 23, square root of negative 22. So we would say that k has to be in between those values. Where it gets a little tricky, is why I said these are kind of tricky ones, is let's see if I can come up with another one here. Let's say instead of 2 imaginary, you wanted 2 real. So it's the same thing. We end up with k squared minus 24, but you would want it greater than 0. So you end up with k squared is greater than 24. So when you square root it, you need to think about your timeline, your number line. You have this, but if we want greater, that's going to be right over here. So k has to be greater than the square root of 24. But we don't want it just greater than negative 24 because we would end up with the square root of negative 23, which is going to be smaller. We want these values because we want that when you square it, it would be the same as these positive values. So our other one would be k is less than the square root of negative 24. So when you're dealing with the 2 on the b squareds, you have to be really careful about your inequalities.